Okay, welcome. We're doing section 7.4. Okay, now this is interesting because we're going to talk about some different case studies about metric to English conversion errors. Okay, the Mars Climate Orbiter, which was a multi-million-dollar project. Although NASA declared the metric system as its official unit system in the 1980s, conversion factors remain an issue. The Mars Climate Orbiter, meant to help relay information back to Earth, is one notable example of the unit system struggle. The orbiter was part of the Mars Surveyor 98 program, which aimed to better understand the climate of Mars. As the spacecraft journeyed into space on September 1998, it should have entered orbit at an altitude of 140 to 150 kilometers above Mars, but instead went as close as 57 kilometers. This navigation error occurred because the software that controlled the rotation of the craft's thrusters was not calibrated in standard international units. The spacecraft expected newtons, while the computer, which was inadequately tested, worked in pound forces. 1 pound force is equal to about 4.45 newtons. Unfortunately, friction and other atmospheric forces destroyed the Mars Climate Orbiter. The project cost $327.6 million in total. Tom Gavin, an administrator for NASA's Jet Propulsion Laboratory in Pasadena, stated, "This is an end-to-end process problem. A single error like this should not have caused the loss of Climate Orbiter. Something went wrong in our system processes in checks and balances that we have that should have caught this and fixed it." Well, there it is. There it was. All right. We also have NASA's Constellation program, a possible casualty of metric English. Another NASA-related conversion concern involves the Constellation project, which is focused mainly on manned spaceflight. Established in 2005, it includes plans for another moon landing. The Constellation project is partially based upon decades-old projects, such as the Ares rocket and the Orion Crew capsule. These figures and plans are entirely in English units. Converting this work into metric units would cost approximately $370 million. Disneyland Tokyo. Tokyo Disneyland's Space Mountain roller coaster came to a sudden halt just before the end of a ride on December 5, 2003. This startling incident was due to a broken axle. The axle in question fractured because it was smaller than the design's requirement. Because of the incorrect size, the gap between the bearing and the axle was over 1 millimeter, when it should have been a mere 0.2 millimeters. The accumulation of excess vibration and stress eventually caused it to break. Though the coaster derailed, there were no injuries. Once again, unit systems caused the accident. In September 1995, the specifications of the coaster's axles and bearings were changed to metric units. In August 2002, however, the English unit plans prior to 95 were used to order 44.14 millimeter axles instead of the needed 45 millimeter axles. Okay, Air Canada. Let me get that. Come on. That should get it closer. Oh, well, it's not going to. Oh, it did. All right. A Boeing airplane. Sorry, had to let my dog in. She was going to have a heart attack out there. Okay. A Boeing 767 airplane flying for Air Canada on July 23, 1983, diminished its fuel supply only an hour into its flight. It was headed to Edmonton from Montreal, but it received a low fuel pressure warnings in both fuel pumps at an altitude of 41,000 feet. Engine failures followed soon after. Fortunately, the captain was an experienced glider pilot, and the first officer knew of an unused Air Force base about 20 kilometers away. Together, they landed the plane on the runway. and only a few passengers sustained minor injuries. This incident was due partially to the airplane's fuel indication system, which had been malfunctioning. Maintenance workers resorted to manual calculations in order to fuel the craft. They knew that 22,300 kilograms of fuel was needed, and they wanted to know how much in liters should be pumped. They used 1.77 as their density ratio in performing their calculations. However, 1.77 was given in pounds per liter, not kilograms per liter. The correct number should have been 0.8 kilograms per liter. Thus, their final figure accounted for less than half of the necessary fuel. Oops! These conversions are important. Here are the references on these stories. Okay, so now we're going to talk about converting between different types of units. So far it's been size of units. Now we're going between different types. American, or what is referred to as English, to metric, or oftentimes referred to as SI, standard international units. Okay. These conversion tables are slightly different than the text. They take the approximations out more places. Okay, there are two sides to the table. One for when you are converting from American to metric, okay, and it's actually telling us that, American to metric, and one for metric to American. When doing the conversion, it is advisable to use the conversion factor we discussed earlier. No, we're going to do it our way. All right. Let's use the conversion factor to solve the following. 32 miles and we want kilometers. So we're going to scroll back up. 1 mile is equal to 1.6093. So 1 mile is, I know I'd forget that amount of time, 1.6093. 1.6093. Stop it. Wow. Sorry about that. That was interesting. 93. That's my problem. I am not using my little pad that keeps my hand from activating the screen. Little pad. There it is. Okay. This is kilometers. So we're able to cross off the miles and gain kilometers. So we have 32. 32 times 1.6093. And I get 51,496, not 51,000, 51. That's a decimal point. That is not a comma. All right. And that's kilometers. 32 inches to centimeters. So let's see what we've got up here. We've got inches to centimeters, so 2.54 centimeters. To 1 inch. We're left with 32 times 2.54. 81.28 centimeters RCM. All right. Now we're talking about for weights and masses. So we're doing ounces to grams, pounds to kilograms, and back. All right, 10 pounds. 10 pounds. When I know that 1 pound is 0.454 kilograms. So we have 10 times 0.45. That's going to be easy. It's going to move my decimal. 4.54. So that's what we have. 4.54 kilograms. All right, so 100 kilograms. We know that 1 kilogram, there it is, sorry, is 2.2 pounds. So we multiply that, and we're going to get 220 pounds. All right. Now we're looking at capacity or volume. Okay, 2.5 pints. We know that 1 pint gives us, 1 pint is 0.473 liters. So we have 2.5 times 0.473, and I get 1.1825. liters. Now, when we look at how many decimal places, if it gives us lots of decimal places to round to, match your smallest number of significant digits. I don't know if you remember that, but notice I have 2 here, I have 3 here, so really 1.9 is all I can guarantee. But if you wanted to do 1.18, that's fine too. Actually, that's probably what I would do, but I'm not a scientist. All right, square inches and square centimeters. So now we're area and some volume, which is cubic inches and milliliters. All right, 2 square inches, 2 square centimeters. Okay, that's our first row up here, square inches. And for every square inch, I have 6.45 square centimeters. And this was 1 square inch, and this had inch squared on it, so I can cross those out. 2 times 6.45 is going to be 12.9 square centimeters. 12.9 centimeters squared. 400 cubic inches. That's actually 2 words, cubic and inch. To liters. Okay, to milliliters, we have what? 1 cubic inch is 16.39 milliliters. But we need to do it to liters. So I know, let's do this multiplication first. Okay, so we can just shift our decimal place. 400 times 16.39, we get 6,556. But to go from milliliters to centimeters to decimeters to meters, not meters, liters, I have to move it 3 places, so it's going to be here. So liters, it's 6.556 liters. All right. Yep, this is the last of it. Okay, comparing American and metric units. Now we look at Fahrenheit and Celsius. Celsius is, we convert using 5/9 and then the Fahrenheit number minus 32 because it sets it back to 0. Okay, now going the other way, it's 9/5 plus 32. 9/5 of the C number plus 32. So I've got 67.6 degrees Fahrenheit. To get C, I have 5/9 times 67.6 minus 32. Okay, so that's 5/9 times, we do our GEMDAS, so we do our parentheses. 67 minus 32 is going to be 35, yes. So 35.6. All right. So now we're going to multiply that by 5 and divide it by 9. 5 times 35.6 divide 9. And I get 19.7777777 forever. Okay, so 19 point, it rounds to 8 C. So 67.6 Fahrenheit is 19.8 C. All right, so wow, we're all the way, that's way at the bottom. This should be moved up. Okay, 3.62 C. So now we want Fahrenheit. So Fahrenheit is 9/5 of the C number, and then we add 32. So we have 9 times 3.62 divided by 5, and then we're going to add 32 to that, and we get 38.516. I'm going to do it to three significant figures, so it's just going to be the 38.5. There we go. Okay, that's the end of 7.